In this video, I'm going to go through assignment 116B, interpreting graph stories. I'm going to go through the 10 examples with you. Example 1 says, during a snowstorm, snow fell at a constant rate for a number of hours. Then it stopped snowing for a number of hours. Then started up again at a different constant rate. Olivia made a graph showing the inches of snow on the ground over time using the data she collected. So on this graph, the x-axis measures the time since the snow began, and y is the number of inches of snow on the ground. After how many hours were there 4 inches of snow on the ground? So to do this question, I just have to find 4 inches of snow, which is right here, and go over and find where the graph is. Hey, the graph is on 4 hours. Number 2. Brooklyn left her house and drove to the store. She stopped and went inside. From there, she drove in the same direction till she got to the bank. She stopped and went inside the bank, then she drove home. The graph below shows the number of blocks away from home Brooklyn is after X minutes after she left her house until she got home. So the higher the graph is, the farther she is from home in blocks. And the farther to the right we go, the number of minutes increases. So how long was she at the store? So the store is the first stop she made. So these two flat spots are the places that she stopped at, right? Because if she's not getting farther or closer to her house, then this line should be a flat horizontal line, right? So this is when she was at the store, because they said here she went to the store first and then she went to the bank. So right here, how long was she at the store? Each block is a minute. So 1, 2, 3, 4, 5, 6, 7 minutes. She's 7 minutes at the store. Question 3, we have another snowfall graph. The x-axis is measuring hours. The y-axis is measuring how many inches are on the ground. At what rate was the snow falling during the first snowfall? So they want to know how fast is the snow falling in this section here. What is the rate of change? Is it 4 inches every 3 hours? So let's go to 4 inches every 3 hours. Nope, there's no graph there. How about 3 inches every 4 hours? Well, it could be that one, right? Because at 3 inches, at 4 hours, there was 3 inches. An inch every 2 hours, that would be up to 1 inch and over to 2. No, the graph is missing there. And 2 inches every hour. That means after 1 hour, there should be 2 inches. And after 1 hour, there's only like a little less than 1 inch. So the answer to this one is 3 inches every 4 hours. Another snowstorm graph. How much snow is on the ground after 4 hours? So we just go to 4 hours here on the x-axis and go up, 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 up. And look to the left. There's 5 inches on the ground. All right, we have a temperature graph here. The x-axis is the time of day, and the y-axis is the temperature. You can see the temperature goes up, stays put for a little bit, and then goes down. At what time did the temperature first reach 54? So 54 is right here. What time is that? That is 8 o'clock a.m. Oops. Question 6. During a snowstorm, where's the graph? There it is. During a snowstorm, there's the graph. How much snow is on the ground when it stopped snowing the first time? So if it stopped snowing, the number of inches should be flat. It shouldn't be changing. So that'd be this little section here. How much snow was on the ground during that time? That was 12 inches of snow, a foot of snow. Example 7, there's another temperature graph. At what rate did the temperature rise from 6 to 10 a.m.? So here's 6 a.m., here's 10 a.m. Is it going up a degree every 2 hours? Is it going up 3 degrees every hour? Is it going up a degree every 3 hours? And is it going up 2 degrees every hour? So at 6 o'clock, it looks like it's 56 degrees. And at 10 a.m., it looks like it's 68 degrees. So 68 minus 56, it went up 12 degrees between 6 a.m. and 10 a.m. So that's 12 degrees in 4 hours, which is 3 degrees an hour. To confirm this, if at 6 o'clock it was 56, 1 hour later at 7 o'clock, it should be 3 more degrees. It should be 59 degrees, which it is, right? So the graph shows that it's 3 degrees an hour. Another temperature graph here. At 10 a.m., 7, 8, 9, 10. 10 a.m.'s right there. 10 a.m.'s right there. Is it rising at a rate of 3 degrees every 2 hours? Is it dropping at a rate of 2 degrees every 3 hours? Is it rising 2 degrees every 3 hours, or is it dropping 3 degrees every 2 hours? So we know it's rising, right? At 10 o'clock, it's rising. 10 o'clock, again, is right here. It's rising. So we just need to see how much it's rising. So at 10 o'clock, it was 59 degrees. And then 3 hours later, 2 hours later. So here's 10 o'clock. 2 hours later, it was 3 degrees warmer. So that means every 2 hours, it goes up 3 degrees. That's this one here. Number 9, another temperature graph. What was the temperature at 10 a.m.? Right there, 56 degrees. And then last example that I'm going to do with you, here's another this is a traveling graph to a store and a bank again. As he heads to the store, so I have to read this one. He left his house and drove to the store. He stopped and went inside. From there, he drove to the same direction until he got to the bank. Then he drove home. So this is the store and this is the bank. As he heads to the store, after how many minutes was Kevin 6 blocks from his house? So we just need to look over here. 6 blocks is right here. And go over. After 1 minute, he was 6 blocks. Perfect. So that's all the examples today. Thank you for watching. Have a good day.